Just by way of introduction, Bridget is a civil and environmental engineering PhD student and Knight-Hennessy Scholar at Stanford University. Bridget aspires to create more sustainable and resilient water systems by linking research, policy, and practice through a one water management approach. In her graduate work, she studied the role that alternative water supply strategies, including water reuse, stormwater capture, and desalination, can play in shaping a sustainable, drought-resistant water supply portfolio. So I will let you take it away, Bridget.
Okay, thank you so much, Shauna. Let me get my slides up. Like Shauna mentioned, my name is Bridget. I'm an environmental engineering PhD student at Stanford, and I study water supply and decision support space in this area. And so today I am so excited to be able to share about a case study that I've done on sustainable water supply through an integrated water management approach. And I want to make sure I acknowledge my collaborators, Paul Shudo, Nagina Shori, and Dick Luthi on this work. The goal of our study was to take a look at Monterey County, California, as a case study for communities in California, in the West, in dry environments, and about the challenges and opportunities that they're facing in developing a sustainable water supply portfolio. And we wanted to share knowledge from Monterey's experience, the lessons that they learned from their successes and also their challenges, to identify areas of focus, be they research or policy, that are needed to support water goals in this space. For my presentation today, I'm going to give an overview of the case. I'm going to talk about one of the key challenges this area was facing at the time of my study, and then also start to bridge the conversation towards the Gulf Islands context through some insights from this case study. Monterey County, California is located on the central coast of California, where this red star is. This area is very diverse. It has residential communities, it has agricultural communities. Some of their main industries include the agricultural production and tourism. So both very water-intensive industries that rely on this reliable supply of water for not only as people's livelihoods, but also their lifestyles. And so this area is, their water provider is a private company, California American Water, or CalAM. And they're unique because they are not tied into any of the federal or state water projects. And so they don't receive imported water from elsewhere. They have to be entirely self-reliant locally for their water supply. And this area was facing some very real challenges on its conventional water supplies. Its main surface source, the Carmel River, it's actually, the CalAM is under a cease and desist order to stop over extracting from this river. And then the groundwater basins in the area are also suffering from this threat of seawater intrusion, and they're also heavily overdrafted. And so the bottom line is that this community had tapped out its conventional water sources, and they needed to look elsewhere to be able to find a supply that was going to sustain them into the future. And their response actually started back in the 70s with some legislation that was passed increasing standards for wastewater discharge into the environment. And rather than a bunch of different communities all sort of individually retrofitting their plants, they decided to form a regional treatment plant that would meet these standards. And then another important part of the vision was using this pooled source of water to then provide water supply to irrigate crops in the region. And so what was born out of this was the Castroville Seawater Intrusion Project, or CSIP for short. This is a recycled water project that took this municipal wastewater source, treated it kind of past the standard that they would need to just discharge it to the environment, to like a higher standard of tertiary from using an additional filtration step and disinfection, so that this was actually a safe water supply to apply to their edible food crops in the area. And this project came online in 1998. It was a revolutionary project and a great first step towards solving the area's water issues, but it didn't fully address the needs that this area continued to have. And so the next piece of the puzzle was a recycled water project for actual potable drinking water supply. And this was Pure Water Monterey. And the way this looks is actually they take the recycled water and treat it to an advanced standard, and then deliberately recharge it into the groundwater supply. And then about 6 months later, extract that water for drinking water use. And one of the really important parts of how this project came online is it didn't just compete with the agricultural recycled water for this same limited pool of water, but it actually was really novel in introducing this sort of unprecedented suite of recycled water sources to help add volume. And these included food industry processing water, urban runoff from the city of Salinas, and a few different drainage ditches that were receiving irrigation return flows from the fields. And this was a really important step to both add volume and to demonstrate how to be able to use more of these waste streams of water. And then the final component for how this project looks, how this recycled water network looks today, is this RUAP project, which takes advanced treated water and applies it for landscape irrigation. And so this diagram here kind of shows how these three recycled water projects are related conceptually. But I also wanted to highlight how this builds out in space. And so here's the area that's all contributing water to that kind of central wastewater treatment plant. And in purple is the area receiving the agricultural irrigation recycled water. In green is the recycled drinking water. Brown shows those novel source waters that were brought online. And then finally, yellow shows the landscape irrigation customers. And so one of the things that was really important about this case is that just as all of these different communities were contributing flows to the recycled water input, they're all seeing benefits from the projects that they've collaborated to create. So pivoting from kind of the development of the system as it looks today, I wanted to highlight a big challenge that this area was facing at the time I was doing my case study. And that was that even with these three recycled projects coming online, the demand in the present time of the area was still just a little bit exceeding what they could legally take from the recycled source, the river source, and the groundwater. And this area had already made a ton of progress in terms of conservation, and they were under some building restrictions and development restrictions. And so the bottom line was that they really needed an additional supply of water. And to do that, they were looking at two different project alternatives. The first was expanding the recycled water project that did the deliberate recharge for potable use. And then the second was constructing a seawater desalination plant. And as I've shown in this table here, these projects differed on a lot of different fronts. First of all, in terms of yield, the desalination plant offered about 3 times the water that a recycled water expansion could offer. But on the other side, it did it at about 3 times the cost and energy demand per unit of water produced. And then on top of that, the intake wells that were proposed for the desalination plant, which I have a schematic of here, there was some environmental justice concern about whether these wells would be sort of illicitly taking water, fresh groundwater from the community that they were located in. And so even just with this very high level overview of the projects, we already see a lot of layers of uncertainty that are embedded in this decision of which of 2 project alternatives to move forward with. The first main one is in terms of yield. Depending on what the future demand of the area would have been, really controlled whether it made sense to need the additional yield that desalination had to offer compared to a recycled water expansion, which was a much smaller volume. Additionally, the impact of the wells was another point of uncertainty because modeling results, depending on who you asked, showed conflicting outcomes. And then kind of an additional layer on top of everything is that Cal-Am, as a private company, there was just a little bit of separation in terms of transparency and accountability. And so there wasn't that trust present between the public and their water provider. And so at this point, I want to just take a brief deep dive into desalination, because I know that that is a topic that has entered into the conversation in the Gulf Islands. And so just as what a typical treatment process would look like is raw water intake from the ocean, pass through a series of filtration steps just to get the water ready for really the star of the treatment process, which is reverse osmosis. And what reverse osmosis does is there's a semi-permeable membrane that allows water to pass through, but not pretty much anything else, and including salt particles, which would be shown here in yellow. And so by applying enough pressure, the plant can actually force the water through the membrane to produce clean water on this side and leave all of the salty water behind. And so one advantage of this desalination as a water supply approach is the reverse osmosis produces really high quality finished water. And then additionally, because the ocean is the water supply source, it's a very drought-proof form of water supply. And then on the other hand, though, some disadvantages is applying that enough pressure to be able to treat the water through the reverse osmosis is very energy intensive. And this energy in combination with the membrane equipment needed can be very expensive. And then finally, when you're left, you produce all this pure water, but you're also left with what's left behind of like the super salty rejected water. And that being disposed of into the environment can cause ecological impacts as well. So that's another concern. And this image I have at the bottom of the slide just kind of like presents how I like to think of different types of water supply, where you have a finish line, which is, safe, potable drinking quality water. And then all of these initial sources of water lie at various distances from this finish line. And so kind of the farther away from the finish line you start, generally the more energy and the more cost it takes to get that water to where it's a potable standard. So bringing this back into the case of Monterey, these two bars here illustrate the water supply portfolios that were available. Everything is the same between the two, except this blue bar here shows the high yield of the desalination plant, and this orange here shows what would be available through expanding the recycled water. And it's clear that desalination offers more water supply total, but really that's important in the context of how much water supply this area is going to need. But unfortunately, this was a point of uncertainty, and these horizontal lines here show where some of the estimates for the long-term demand of the area were coming in. And you can see that, like, depending on which estimate you go with, really changes the decision of whether or not both portfolios would be adequate or whether you might need the additional yield of desalination. So another way that the area framed this question is like, okay, like, if we can't decide on what the long-term demand of the area is going to be, let's think about how it might grow out from its present status. And so this presents the idea of asking the question of, like, given the current demand, if that's going to grow at a certain rate, how long would it take before the growing demand would outpace what would be available through a recycled water expansion project? And this plot here shows 4 different studies from 4 different authors over a pretty short period of 3 years that answered anything from 5 to 30 years to that question of how long would recycled water see this community through. And so, I don't know, so in some ways adding some insight, in some ways introducing additional complexity. And so one thing that I wanted to highlight about this case is that, there are a lot of different fronts of uncertainty with what the desalination intake wells would be doing to local groundwater, with what the long-term demand was of the community, with how fast that demand might grow. But I wanted to highlight that the actual debate and discussion around this really largely happened around a single permit, the coastal development permit, that the CalAM's desal project would have needed to move forward. And so this happened at the local level. It got appealed to the state level. There's a lot of public involvement. This image here shows the public comment period at a state hearing on this project. And this is like a jam-packed room, an all-day meeting, literally hours of comments for and against the desal project. And so I thought it was really important. We like to talk about, demand and supplies and hydrology, but for this case, this is really where that decision ended up happening. And so thankfully, for the purpose of today's presentation, I can provide a little bit of conclusion to this chapter that a little over a month ago, CalAM Water Company agreed to the recycled water expansion. And so the door is open in the future if it turns out demand does outpace what the recycled water can provide. The desalination plant is not off the table. But I think what's really important is that the community, took stock of what they knew, where the uncertainty was, and where the preference of their stakeholders were. And so then they decided to make this the next chapter of their story. So tying this together into some insights, one of the things that was really important with how Monterey handled this water supply planning was to involve stakeholders early and often, to prioritize building trust, to recognize uncertainty, and so to build in project designs that were able to adapt to more knowledge gained as the future built out. One thing also, an important way for how you don't often have the public calling for recycled water instead of against. And so I think one thing that was really important was placing this in the context of like concrete local needs, so that it's not just a debate about the abstract, but we can put a place on it. I've listed here just many of the agencies that were involved in these projects becoming a reality. My co-author, Paul, was in the room as these discussions were happening, and he described it as like a house of cards. And so very precarious early on, but able to build something very strong eventually, because these different agencies are contributing a shared vision for where they want their water supply to go, and also able to pool resources, shared infrastructure, and expertise to make it happen. And then one final comment is just the nuts and bolts of actually making alternative water supply happen, is that a recycled water or a desalination or a recharge is going to be more expensive than just pulling water from the ground. But a way to make that, to equitably make that happen, is to think about everyone who's benefiting from those projects and distribute the costs accordingly, so that it's not just a small group that might be shouldering the burden of an entire region's water supply needs. So bringing this all together, just kind of, hitting on prioritizing public outreach and trust, using adaptive planning to navigate uncertainty, and thinking about how these projects are going to be implemented in practice, and for equity and for affordability, were all just really major components of Monterey being able to move forward with this kind of very innovative water supply solution. So of course, there are many continuing challenges, but I think that with what they've developed in terms of decision-making and procedural equity, I think that that will reflect the ability to be able to handle these continuing challenges. And so I'll leave it at that for today, but I want to thank everyone so much for your attention, and I look forward to continuing our conversation in the Q&A.